Hello students, we have made friends with the double angle formulae, the additions formulae, trigo identities. So in this video, we're going to make friends with the R formula. Right, to begin, we're going to look at the concepts behind the R formula. Let's start off by asking ourselves these questions. Why do we learn the R formula? Right, supposing you're asked to solve this equation. So based on all the concepts we have learned so far, how would you do it? Right, let's explore our options. We have learned the Pythagorean's identities, the double angle, and the addition formulae. So all of these three, which one do you think we can use to help us to lay the foundations for the R formula? Supposing, is there another way of rewriting square root 3 over 2 cos x plus 0.5 sin x equals to 0.6? Yes. If you were to recall that cosine 30 is actually square root 3 over 2, we can actually replace square root 3 over 2 with cosine 30. And we can replace 0.5 with sine 30. And with that, which formulas on the left do you think we can use to rewrite cos x cos 30 plus sine x sine 30? Right, we can actually use the addition formulae. Right, so how do we use it? Yes, so we can actually rewrite cos x cos 30 plus sine x sine 30 equals to cos the bracket x minus 30. And hence, we can actually solve the equation cos bracket x minus 30 equals to 0.6. Because the whole equations will only involve one trigo functions. And that is manageable. So using this knowledge learned, all right, we're going to derive the formula to solve trigo equations of the form a cosine theta plus minus b sine theta, or a sine theta plus minus b cos theta. And the formula we're going to learn, it's called the R formula. Right, so we're going to use the addition formulae to help us derive the R formula. Right. So supposing I have I'm given the equations in terms of sine theta and cos theta. So for example, the earlier one that I'm given is square root 3 over 2 cos theta plus half sine theta equals to 0.6, right? It can be 2 cos theta plus 3 sine theta, right? Equals to something. Or it can be 1/4 cos theta plus 10 sine theta, all right, equals to something. So what I'm saying is that I can just let this value here, the number that is in front of cos theta, be A, right? Because it can be any value, right? We don't know what kind of equations will be given. And likewise, this value here that is in front of your sine theta, it can be any value. So we're going to let it be B. Right. And we know that regardless of whatever values we have for A and B, we can actually express it using the addition formulae. So we're going to let it equals to r cos bracket theta minus alpha. Right, and we need to find the formula. We need to find the formula to find the values of r and also alpha. Okay, I hope you understand my explanation. Right, so the next thing is that we're going to use addition formulae to expand this one. So that will give us r cosine theta cosine alpha plus r sine theta sine alpha. All right, so the next thing is that I'm going to do some comparison. So what am I going to compare? Yes, I'm going to compare a cos theta on the left with r cos theta cos alpha on the right to form one equation. And I can just divide by cosine theta on both sides. To get a equals to r cos alpha. So that will be one equation. Likewise, b sine theta, I can form equations with my r sine theta sine alpha. And I'm going to divide sine theta on both sides. I would end up getting b equals to r sine alpha. Second equation. All right, so what I'm going to do is I'm going to square equation 1. That means I'm squared the left-hand side. That means I square a to get a squared. And I square r to get r squared. Square alpha, cosine alpha means cosine alpha times another cosine alpha. So that will give you cosine alpha squared. Cosine square alpha, sorry. Cosine square alpha, sorry. Okay. Likewise, for equation 2, I will get b squared equals to r squared sine square alpha. Okay, so what I'm going to do with these two newly formed equations, I'm going to add them. Okay, and you see that r squared is a common factor, which I'm going to factorize it. Right, and if we were to remember, this is one of our Pythagorean identities, and that gives you 1. So you have r squared equals to r squared times 1, that gives you r squared. So r squared equals to a squared plus b squared. So r is square root a squared plus b squared. So in other words, if I know the values for a and I know the values for b, okay, I just plug in inside here, I'll be able to find the values for r, which account for this. So the next thing is that I need to find alpha. So I'm going to take equation 2 to divide by equation 1, okay, and I'll have tangent alpha equals to b over a, so alpha will be tangent inverse b over a. So if I know the values for b and the values for a, I'll be find alpha. So with all these values that I find out, I can just plug it into here, and then let this equals to whatever value that I'm given, and I can just solve it. Okay, so this is called the R formula. Right, let's do one example. Okay, supposing we're asked to solve cosine x plus 2 sine x equals to 0.6. All right, so we need to compare it with our a cos theta plus b sine theta. Remember, this is equals to r cosine bracket theta minus alpha. Right. And we can see that a is equals to 1. And your b is equals to 2. And if we were to record in the earlier on slide, to find R, it's equal to square root of a squared plus b squared. So you plug in the values for a and plug in the values for b, you can find the values for R. Likewise, alpha will be tangent inverse b over a, and that gives you tangent inverse 2, that gives you 63.43 degrees. So once we know all this value, we can just plug it back into this one here, the one I've highlighted. Not highlighted, the one I've underlined in green. Okay, and with that, I can actually solve the equation in the next slide. Okay, right, so I'm going to divide by square root of 5 on both sides. Right, so do you remember how we go about solving trigo equations? Yes, we're using the concepts of ASTC, which require us to find angle alpha, which is your basic angle, reference angle, which is an angle that is more than 0, less than 90. Correct. Under the ASTC for cosine, to get a positive value, the angle will come from the first and the fourth quadrants. So that's find alpha first, which is just cosine inverse 0.2683. All right. So to get the answer from the first quadrant, and then answer from the fourth quadrant will be just 360 degrees minus alpha. And x will then be 349.0 degrees. So this is how you can actually use the R formula to help you solve equations in the form a cos theta plus b sin theta. Right, so the next questions we need to ask ourselves is, what happened if you're given a cos theta minus b sin theta instead? All right, so we're going to extend our knowledge into what happened if you're given a cos theta minus b sin theta, or if you're given a sin theta plus b cos theta, or a sin theta minus b sin theta, a sin theta minus b cos theta, then how do we actually tweak the R formula to fit into the equations that we are given? Yes, so if you look at the table, if you're given a cos theta plus b sin theta, then basically the R formula will just be R cosine bracket theta minus alpha. All right, so look at what happened. If this is a plus, then this guy is a negative. If this is a negative, then this is a plus. Right, and if you write, okay, for the first two examples, your cos theta actually appeared in the first position. In this third one, can you see that the sin theta appeared first, followed by cos theta? And if that is the case, it's not R cos, it will be R sin. Okay, and if it's plus, this is plus. If this is minus, this is minus. Right, so the way to represent your a cos theta plus minus b sin theta or a sin theta plus minus b cos theta are different. However, the formulas to find R is the same, which is still square root a squared plus b squared. And the formula to find alpha is still the same, which is tangent inverse b over a. Right. Actually, it's not very difficult to answer these questions. All you need to do is just to go back to the addition formulae, and you will understand why, okay, that the sign or the cos plus become minus, minus become plus. Because remember that the R formula is derived from the addition formulae. So you just go back to look at your addition formulae for cosine and sine, and you understand why. Right, so for R formula, basically, these are the three different types of questions you will encounter. Okay, the first type is you ask to find the exact maximum minimum values of 6 cos theta, for example, okay, 6 cos theta minus 4 sine theta minus 2. So that will require you to write this, express it in R cosine bracket theta minus plus alpha, okay? And then from there, you find your maximum minimum value. That's one type of questions. Another type of questions is like what we have done just now. Solve it, write it in the form, in the R formula form, which could be R cos bracket theta plus minus alpha or R sine bracket theta plus minus alpha. Okay, depending on the positions, whether your cos come first or your sine come first. And then you solve the equation. And of course, the last one, which is the more difficult one, is problem sums. Okay. All right, so we're going to look at example 1. Right, so the example 1 is the one that in the earlier on slides, the questions that I've told you, one of the typical questions that you may encounter in this chapter. You ask to find the exact maximum minimum values for 6 cos theta minus 4 sine theta minus 2. You can't tell at all, okay, the maximum and minimum value for that, the one circled for you in purple. So but if you write it in the form, in the R formula form, we'll be able to tell. Right, so the first thing is, which one do we use? Yes, of course we use that, right? We use this. You can put this answer insert or as a 4 significant figure for in between answer, final answer 3 significant figure. Then you can go on to find alpha. Oh, sorry, you have to leave it insert because my question here says exact. Oh, that's why there's these questions for you to ponder. How would the answer be like? All right, so because it's exact, so you can't leave it in 3 significant figure. It has to be insert form. Right, but alpha is okay. You can leave alpha as one decimal place. In between is 2 decimal places. Final answer is 1 decimal place. All right, so you will see that after finding your R and your alpha, you can just plug it into your R cosine bracket theta plus alpha, right? So your R is 2 square root 13 and alpha it's 33.69 degree. Okay, so in the earlier chapter, if you've already forgotten, please go back and look at, I think it's chapter 10, when we talk about the trigo curves. We mentioned about maximum minimum point, right? So the maximum value for this will be 2 square root 13, and the minimum value will be negative 2 square root 13. Okay. Hence, the maximum value for 6 cos theta minus 4 sine theta. Okay, so your 6 cos theta minus 4 sine theta, it's what we found earlier on to be 2 square root 13 cosine bracket theta plus 33.69, right? Okay, I need to minus 2 because we're actually finding 6 cos theta minus 4 sine theta minus 2. So that explains why I need to minus 2 throughout. because we're actually finding the maximum value for 6 cos theta minus 4 sin theta minus 2. So from here, we can see that this will be my maximum value. Right, and to get that having maximum value, it's when I need to let cosine bracket theta plus 33.69 degrees to be 1. Okay, and if you were to recall your cosine curve, right, there are two angles that gives you y equals to 1. One of them is theta equals to 0 degree. The other one is 360 degree. We don't use 0 here because if you use 0, then your theta will end up having a negative value. Our angle theta must be between 0 degrees and 360 degrees. So therefore, we don't use 0 degrees, we use 360 degrees instead because we want a positive value. We want the angle theta must be between 0 and 360. Okay, so the minimum value would be negative 2 square root 13 minus 2. And that happens, okay, if you were to, that happens is when you let your cosine bracket theta plus 33.69 degrees equals to negative 1, right? And again, go back to your cosine curve. That's why you need to make friends with the cosine curve. It's very important, all this value here. Okay, cosine 180 degrees will give you negative 1. That's explain why I use 180 minus 33.69 degrees to give you 146.3. So this is one kind of typical questions that you may be tested on using the R formula. Okay, another one will be this kind. Solve the trigo equations. So we're going to express this in the form R cosine bracket theta plus alpha. Okay, so similarly compare it with your A cos theta minus B sin theta. So from there, we can see that A is 1, B is square root 3. So you can plug into your R and find alpha. Okay, and this is what you get. So you can just solve it. All right, so which is relatively easy. There are two angles that gives you, remember your cosine curve. To get cosine theta equals to 1, theta can be 0 degrees or 360 degrees. Okay, but if you use 0 degrees, then you end up theta equals to negative 60. So we need to reject the answer because your angle theta has to be between 0 degrees and 360 degrees. So negative 60 degrees is out of the range. So the only answer will be 300 degrees. Okay, what is method 2? Right, so method 2, it's instead of writing cos theta as in the first position, I rewrite the whole thing lah. That means I write sin theta to be in the first position. So that means I express the equation in the form R sin instead of R cos. But I think don't do that. Don't do that way. Okay, I'm just trying to be funny to show you because in my example, I didn't really have questions, where you express sin theta in the first position. So I'm just telling you like if you happen to have the situation, then how, okay? You still get the same answer. Okay, I'm going to show you. You still get the same answer. See, you still get the same answer for R, same answer for alpha. Okay, except that of course, if you're talking about sine curve, to get sine theta equals a -1, then your angle theta will be 270 degrees. That's the difference between your sine curve and your cosine curve. This angle is 270. All right, if what I have just said doesn't make sense to you, please revise your trigo curve. Okay, go back and revise your trigo curve, then you understand what I'm talking. All right, so let's look at the last example, which is a problem sum. Okay, it may look a bit scary, but actually it's not. Honestly, the more words you see in the problem sums, the easier the question is. The scary thing is the kind of questions where you just give you a few words and you don't know what to work on. All right, so you have a semicircle, radius is square root 12, center O, and then there's a triangle, okay, inside your semicircle. So of course we know that if your xy is a diameter, then your xzy will be 90 degrees, right? Right angle in a semicircle. So we're supposed to show that the parameter p units is given to be 4 square root 3 bracket 1 plus sine theta plus cos theta, and then the area is 12 sine 2 theta. Okay, so how do we go about solving it? Yeah, okay, that is right angle in a semicircle gives you 90. Right, so we need to simplify your square root 12. Square root 12 can be, is a third, can separate it into square root 4 times square root 3. Okay, and from there, I can use your trigo ratio to find zy. And I can also use sine ratio to find xz. Because remember, we are finding parameter. So you want to find parameter means you have to find xz and zy, right? Add them together and plus another xy, right? To gives you the perimeter of your triangle, right? Okay, so it's not difficult, you see. It may appear to be scary, but it's not. Basically, you're just using trigo ratio, which is something you have learned before, also using surds. All right, how about the area? Area is even easier. Yes, half times base times height, because xzy is a right angle triangle. Okay, the only tricky part here is that you have to use your double angle. Okay, that's the reason why you have to make friends with all your double angle formula, your addition formula, R formula, make friends with all this formula. Okay. Okay. So basically, I need to separate 24 to be 12 times 2 so that this one is actually your double angle for sine theta. It's sine 2 theta. Okay. Right. So if you don't make friends with all the formula, you wouldn't know how to evaluate from here. You wouldn't know. But if you know your double angle sine 2 theta is 2 sine theta cos theta, then that will give you an idea to write 24 as 12 times 2 so that you can group this and then it equals to sine 2 theta. So that's first part. All right, so second part is easy already. Why easy? Okay, because second part you can just basically apply the R formula. Right, so we're going to let this equals to R sine. Okay. So this is now is the opportunity. Okay, we can express it at R sine bracket theta plus alpha because my sine theta come first now. Okay, and anyway we are asked to do it, so you don't change the position. since the question specifically asks you to write it in the form r sine bracket theta plus alpha. Alright, so A is 1, y1, okay, this is 1, this is 1 also. So A is 1, B is 1, so R is square root 2. So alpha will be tangent inverse 1, which is 45 degrees. Okay, so we can open up the bracket. Open up this bracket. Why would you open up bracket? So that I can substitute in my R formula for sine theta plus cos theta. So you open up the bracket, you will have 4 square root 3 times 1 gives you 4 square root 3. 4 square root 3 times this guy here, give you this. And then you just substitute your sine theta plus cos theta with this, which you have already found the values for R to be square root 2 and your alpha to be 45. Okay, which is what the question requires us to do in part 2 lah. Okay. Then for part 3, and then you just take 4 square root 3 times square root 2 will gives you 4 square root 6. So for part 3, you just solve it only when P is 14.5. Okay, so basically it's just solving trigo equations, which you should be proficient in doing it now. If not, then please revise. Right. Okay, so find alpha. Alpha at sine inverse 0.7728, which is 50.61 degree. So your theta will be possible to have two answers. Okay, possible to have two answers because your theta is between 45 and 90. So it can be in the first quadrant or second quadrant, right? For sine to be positive, right? You under your ASTC, first or second. First quadrant is just alpha. Second quadrant is 180 minus alpha. Then from there you can find your theta. Okay, why you need to reject the first one? Yeah, because your angle is between 45 and 90. So 5.61 it's so small. Okay, it must be between 45 and 90. So therefore you reject the first answer. So your angle theta is 84.39. Oh, you should express it to... Oh no, after that we still have to find A. Area, the values of A. So finding theta is not the end yet. You have to substitute into your formula for finding area in the earlier slide, which is 12 sine 2 theta. Then substitute theta will be 84.39. Oh, that's the reason why I leave it in 2 decimal place, because it's in between answer. Okay, and then final answer is 3 significant figure. Okay, so this video concludes the whole lessons on the concepts of R formula and how we can use it to solve the kind of questions that you may encounter in your test or in the exam. So happy learning.